Okay, video about trig ratios of any angle. So this is what we talked about in class, where we are going to stick our angles on a grid now, an XY plane. So here you've got an XY plane, and we're gonna do all angles this way. We're calling this in standard position. So we're having the initial arm of our little angle situation on the x-axis, on the positive x-axis. So we called this the initial arm. And then the terminal arm is going to end up in any of the four quadrants. And the terminal arm is this guy. And that's just going to tell us where our angle is located. So there's our initial arm, there's our terminal arm, and that means our principal or our primary angle is going to be right in between those. So that's our primary angle. It's the angle we're talking about. And this is standard position. So when we start here at the initial arm, that's 0 degrees. And straight up is 90 degrees. All the way over is 180 degrees. Down at the bottom is 270. And then back around to the beginning is 360 degrees. And it can keep going. So you can keep going around and around all the way through 720, and it can just keep going forever. And if you notice, we're going in a counterclockwise direction for all positive angles. But we can actually have negative angles too. So if we go in the other direction, that's where we talk about negative angles. So 0 is still here, 0 degrees. But if we go in this direction, this is actually negative 90 degrees, negative 180 degrees, negative 270, and then back over here, negative 360. So this is just this is what we describe as standard position. And we're going to find the trig ratios of any angle. So let's say we wanted to find, let's say we were given a point. Given the point 4, 3. We're going to stick it on a graph. We're going to use a circle to help us find the 3 trig ratios at this point. Just using this as an example. So here's our XY plane. And we'll just use a random circle. Okay, that's a horrible circle. Let's use like a random circle to help us figure this out. So our point is at 4, 3. So we're just going to say that's 4, 3. Okay, so this point is at 4, 3. So, here's our initial arm and our terminal arm. And here's our primary angle. And then we have to turn this into a triangle here. So we're going to connect it to the x-axis so you can have a right angle triangle. 4 is our x value and 3 is our y value. And then in order to figure out our hypotenuse, we're using the Pythagorean theorem. So 4 squared plus 3 squared is going to equal r squared. So r is equal to the square root of 16 plus 9, so the square root of 25, so r is 5. Okay, so if we wanted to figure out what our 3 trig ratios would be here at this point, 4, 3, then we can write down that sine theta, its sine is actually opposite over hypotenuse, so sine is always equal to y over r, which in this question is equal to 3 over 5. Cos theta is equal to x over r, which in this example is 4 over 5. And tan theta is equal to opposite over adjacent, so y over x, which is 3 over 4. So those are the exact values of our 3 trig ratios. And if we wanted to find out what theta is, we could pick any trig ratio. So say we picked sine. So sine theta equals 3 over 5. And we could just use our sine -1 of 3 over 5. Punch that into a calculator. So sine -1 of 0.6, and we would get 37 degrees. So we know the angle there, theta, is 37 degrees. So say we did the same question, but this time, let's use the point. Say we were going to use the point over on the other side. So let's use a point -4, 3. And let's see how that affects our values. So now we're going to use this point over here. So there's our terminal arm, and our initial arm is still here, never changes. But we still need to make a 90-degree triangle, and we always connect our triangle to the x-axis. So there's our triangle. So it turns out theta is now going from here to here. So this is theta now. So it's going from the initial arm to the terminal arm. But our triangle is actually over here. And we're going to call this angle in here the related angle. I'm just labeling it with Greek letter B, beta. Okay, so our length down here is -4, down here, and then the y is 3, and then our hypotenuse is still 5. Okay, so we found out theta in here was 37 degrees. So let's figure out our primary trig ratios for this triangle. Okay, I'm just going to erase our angle calculation here. Okay, so let's figure out our 3 trig ratios. So we've got sine theta equals y over r, so 3 over 5. So the sine ratios are identical. This one was 3 over 5 as well. Then we've got our cos ratio, which is x over r, so -4 over 5. So they're slightly different. This one's negative. And then our tan ratio is opposite over adjacent, so y over x. So 3 over -4, or -3 over 4, whichever way. So they're slightly different too. So it turns out cos and tan are negative in that quadrant, but sine's actually the same. If you wanted to find the angle there, for this blue angle here, I mean, sine is identical, so you think if we do the exact same calculations, we get the exact same angle. So theta equals inverse sine of 3 over 5. We're going to come out with 37 degrees again, which is clearly not this blue angle here. It's not 37 degrees. So in order to figure out what that primary angle is there, the 37 that we figured out is actually right here in our triangle, of course. So that angle is 37. So if we wanted to figure out the blue angle, we'd have to do 180 degrees, because 180 degrees is the full thing, and then we'd subtract 37. So we get 143 degrees. So that's what theta equals. Okay, let's try one. So let's do this differently. Let me give you an angle this time. So let's try to find exact values. Exact values of, let's pick an angle, like 300 degrees. So we want to find exact values of, not of 300, but exact values of the primary trig ratios. primary trig ratios for 300 degrees. So if we stick that on a graph, so we stick it on a graph, 0 degrees, 90 degrees, 180 degrees, 270. So we're going to be somewhere in quadrant 4 here. So we're going to say, so remember our initial arm is always on the positive x-axis. So we're going all the way around, and that is 300 degrees there. And we're going to try to find the exact values. So we always attach our terminal arm to the x-axis. So we're attaching it to the x-axis to make a 90-degree triangle. This right here is our related, this angle inside of our triangle is our related angle, and that's going to be 60 degrees, since all the way around is 360, which makes this angle up here 30. So this is one of our special triangles. So we can label our special triangles with root 30, 1, and 2. And I know this root 3, 1 and 2. And I know root 3 over here is actually going to be negative because it's going down. 1's going to be positive, and our hypotenuse is always positive. So there's our special triangle. So if I wanted to find the exact values of my 3 primary trig ratios for 300 degrees, you can just write them out. So sine of 300 is equal to y over r. So negative root 3 over 2. Cos of 300 degrees is equal to x over r. So 1 over 2. And cos of 300, or sorry, 2. Okay, so then, sorry, tan 300 degrees is equal to y over r. So y over x. So negative root 3 over 1. Awesome. So we can given an angle, we can graph it in whatever quadrant it's in, and then possibly use our special triangles. If this related angle is 30, 60, or 45, we can use our special triangles to find exact values of our primary trig ratios. Okay, stop watching at any time. This is the longest video ever. But if you want to do another point question, so let me give you another point to try out. So say you have the point negative 5, negative 12. So you're going to graph that on a grid. So we're going to figure out, okay, negative 5, negative 12. So negative 5, it's going to go this way, negative 5. And then negative 12. So you're going to be somewhere over here. So I can draw my terminal arm, and I can connect it to the x-axis, saying negative 12. And then I can find r using the Pythagorean theorem. And I know my principal angle is all the way from my initial arm, which is over here, all the way to my terminal arm. So that's my theta that I'm trying to figure out. So let's calculate r. So r is going to be the square root of negative 12 squared plus negative 5 squared. So 144 plus 25, which is 169. And the square root of 169 is 13. So r is going to be 13. So now to find our trig ratios, we just use our values. So sine theta equals y over r. So negative 12 over 13. Cos theta equals negative 5 over 13. And tan theta equals negative 12 over negative 5, which we can just say 12 over 5 since the two negatives cancel out. So those are our three trig ratios. And if we wanted to find out what theta equals, we just take any one of our trig ratios. So I'm going to take tan theta equals 12 over 5. And I'm just going to calculate the inverse of that. So tan negative 1 and 12 over 5 is just 2.4. So to take the inverse of that, you get 67 degrees. Okay, so clearly 67 is just the angle inside the triangle. So if we wanted to get the entire thing, so we just take 67 and add it to 180, because that's what this straight line is, 180. So 180 plus 67 gives us an angle of 247 degrees. So theta is actually equal to 247. So I probably should have called this like beta, because technically here we're just solving for our related angle. Okay, and then I don't know if you guys know, it turns out there's this rule called the cast rule, C-A-S-T, cast rule. So the cast rule, it's not a big deal. It just tells us which ratios are going to be positive and which ones will be negative. So C means cos will be positive. A means all of them will be positive. S means that sine will be positive, and T means that the tan ratio will be positive. So if you look back at all the other examples, remember when we did like the 300-degree example? When we did our like ratios, all of them were negative except cos of 300 ended up being a positive ratio, whereas sine and cos were negative. So that's what that is. Okay, the end.